Hello guys, in this video we are going to discuss the solution of the problem make binary tree from linked list. So let us look at the problem statement. The problem statement says that given a linked list representation of a complete binary tree, the task is to construct the binary tree and print the level order traversal of the binary tree. So what we need to do is a linked list is given to us. So let us say this is the linked list which is given to us. We need to construct a binary tree from this linked list. So that's the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say the linked list which is given to us is this, and let us write down the indexes as well. So this is my 0th index, first, second, third, and fourth. Now using this linked list, I need to convert binary tree. So let us see how we will be able to convert it to a binary tree. So the first node is my root node. Then the left child exists at, so the left child will be at position 2i plus 1. And similarly, the right child will be at position 2i plus 2. So let us plug the value of I equals to 0 in order to get our left and right child. So the left child will be 2 and the right child will be 3. And let us write down the indexes as well. So this was at index 0, this is at index 1, and this is at index 2. Now for node 2, let us plug the value of I equals to 1 in this equation in order to get our left and right child. So as we can see, the left child will be 4 and the right child will be 5. And for 3, if we plug the value of I equals to 2 in this equation, then we can see that it goes beyond the boundary of the linked list, because of which the left and right node of third node is none. So from here we are able to deduce our algorithm, and the algorithm is, first we convert the linked list into an array. And the reason why we are converting linked list into array is because we want this computation to be done in order of one time. And once we have converted linked list into array, this computation can be done in order of one time. So once we have converted into array, then our task is to essentially convert this array to tree. And that's the whole algorithm, folks. So now let us see how we will be able to convert the linked list into array. So list to array is a function which takes head of the linked list as an input. Now what we are going to do is, we are going to have an LL array with us, and then we are going to iterate on head while head is not equals to none. And while iterating, all we have to do is we have to append head data onto the LL array. And after doing that, we just have to increase our head pointer to the next element. So head equals to head dot next. And then we can return LL list which we have created. And in this way, we will be able to convert list to array. Now once we have converted list to array, now our job is to convert the array to tree. So let us see how we will be able to do that. So let us say there is a function array to tree, and an array is given to us, and let us say the I is given to us, and initial value of I will be equals to 0. So we are starting from I equals to 0, and now let us see if I is greater than or equals to length of array. That simply means it is going beyond the bound of array, because of which we can safely return none from here. Otherwise, what we have to do is we need to create a root node. So root, which will be equals to tree node array of I. So tree node is a constructor which takes one argument as an input, which is array of I, and it will create a tree node for us, which will be essentially where the root of data equals to array of I, and the left and right child is none, initial value. Okay. And then once we have our root node with us, all we have to do is construct it left and right child. So the left equals to, and where is our left child? Well, the left child is at position 2i plus 1. So array to tree, and array will go as it is, and instead of I we are now sending 2i plus 1. And similarly for right child, it will be array to tree, array, and 2i plus 2. And in this way we have constructed our entire tree, and once we have constructed our tree we just have to return a root. And that's the whole pseudocode, folks. Now let us see how we have implemented this in Python. So the implementation is pretty much the same as what we have discussed in our pseudocode. So we have an array which is ll with us. Now we are iterating on linked list to form the ll array. Once we have ll array, then we are converting linked list to tree, and ll is the array and 0 is the starting position. And then towards the end we are returning root. Now let us look at ll to tree function. Here, if it is going beyond the range of the array, then we are returning none. Otherwise, data equals to ll of I, and then we are creating our tree node. Once we have created our tree node, then the left and right child is something which is populated like this. And towards the end, we are returning root. So that's the whole code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.